Good day, my people. How was your day? Okay, today we're going to looking at universal logic gates, NOR and NAND gates. Yeah, man. Now, our NOR and NAND gates, we said previously in one of our videos that it is actually known as what? Universal gates. Now, the question is, why do we call NOR and NAND gates universal gates? The NOR and NAND gates, they can be used to implement other forms of logic gates. That is including the fundamental and the advanced, and even themselves. You can actually use one of them to actually implement the other. So that's what this video is going to be all about. Now, we'll be first of all working with our NOR gate, and we'll be using our NOR gates to implement other forms of gates, other gate types. Now, your NOR, we know that our NOR, this is a symbol. Sorry, this is NOR, not OR. This is our NOR, and the bar is a important distinction between it and the OR gates. And then you have your output here. Let's call output F. Now this is a symbol. Now for our expression, our output to be what? A plus B or bar. So we're going to be using this logic gates to get every other one. So we're going to be having 6 logic gates. We're going to be using this one particular logic gate to get. So we have used our NOR to implement our NOT. Now, how is this true? Now, what this is telling us here from this, what we're meant to be having as output is meant to be A will go in here, and that A will also go in here. I'm splitting it into 2 from this junction. Split it into 2. One went here, one went here. So A times, no, this is plus, no. So we're having A plus A, or what? Bar. And you know, in logic expression, when you are adding the same variables, you just take one. This is equivalent to what? A bar. So this has been proven that actually this is actually the what? The logic expression of what? Your NOT gate, using your NOR gate to represent it. Now we'll move over to the next one, which is our what? OR. We know that our OR is what? This is what our output is meant to look like. If we are having 2 outputs A and 2 inputs A and B, this is what our output is to look like. But we know that our NOR on the other hand is what? A plus B or bar. So we are looking for a way to get this output having only this in hand. So this is how we do it. Now, before I go further, I would like us to know this. I'm sure by now we're supposed to be familiar with this. A bar is equivalent to A. I hope you know this, because we are going to be making use of this. And another thing we're going to be making use of is your De Morgan's rule, which is your A plus B or bar is equivalent to what? A bar dot B bar. The idea here is, if you are to split this bar on top, the sign will change. So also will this. This has already been explained in one of our videos, but I'm bringing it up because we're going to be making use of these 3 laws to understand this topic. So when you're splitting your bar on top, the sign changes. That's just the idea here. So we need to have this in mind, that A double bar is A, and this is this. Okay, now with that aside, let's go back to this. Now we're looking for a way to use A plus B or bar and turn it into what? A plus B. So if this kind of question is given to you and maybe you don't remember how the diagram used to look like, or maybe because I see most people, they just cram the diagram, but there's actually a way you can actually solve it and know the answer. The idea is this. When you are asked to use any of the universal gates, in this case NOR, to implement another gate, Write the expression of that gate as we have done like this. Now you double bar it. What we did now is what? You just double bar this. This is always the first step. When you get any expression, you double bar it. Now this is still equivalent to what? A plus B. We haven't done anything special. But by double barring this, if you are to consider only just this brackets, this is your NOR. And this other one can then serve as your what? Your NOT. And since we already established what a NOT would look like, we can then get a logic diagram for our OR. And it will be like this. Taking just the NOR part, we're going to be having A and B, and our NOR symbol. That's for the one in the bracket first. So we know at the output, we're going to be having this will be what? A plus B, or what? Bar, which is representing this what? This bracket. And the other one, which is the NOT, we are going to be repeating this again. Repeating this again. So that we have that our output will be A plus B double bar. And we know that A plus B double bar is also equivalent to what? A plus what? B. So I hope you grab the idea. We also do an for and. So you will see the same thing to repeat itself again, the same step. First, when you are asked to use to use any of these universal gates to implement this, write down the expression of that one that you are meant to implement, which is, for in this case, I'm meant to use NOT to implement NOT OR. We wrote down our OR expression and we double barred it. Let us do for our AND, so we also see the same steps, repeating themselves again. Now for our AND, which we know that it is what? A dot what? B. Now we'll write down this expression again. A dot what? B. Now double barring this, our aim here is to eliminate this sign over here. This sign over here, which is the multiplication sign. Our aim is to eliminate it. And thank God for De Morgan's rule that says that when you are, for you to split the bar on top, you have to change the sign, which is what we want. So we can actually write this to be what? A bar plus B bar, or bar, or what? Bar. Now looking at this, you have a negated B, a negated A, and in all of them you have your what? Your NOR. So this is what we're going to be using to draw our diagram. So the idea here is, after double barring it, let the multiplication sign change to what? Plus, because what we are only meant to use is only what? NOR. NOR. We don't want to use any multiplication there. So we just did that now. So coming over here, our diagram will then be A, B. We're going to be negating it with this same symbol. So that's why the inverter diagram was the first one we started with, because it will help us to achieve a lot of things. Now we have done this part. This is, so at this part we'll be having our B bar, and at this part we'll be having our what? A bar. Now what is left for us now to do is to what? To NOR it, which is what? Just joining the two of them together and getting your what? Your output. And in this case, our output will be what? A bar plus B bar, or bar, which is also equivalent to what? When you are to split this sign, you have A dot B double bar, which is equivalent to what? A dot B. Hmm? Okay. So what is remaining is our XOR and our XNOR and also our NAND. So let us try for NAND first before going over to the advanced ones. Okay. Now for our NAND, the same thing goes again. We write down our expression A dot B or what? Bar. We just double bar it. Let's double bar it. Now splitting this, remember we double bar, not only just one bar, so that we can also get back our words. This is the expression for your NAND. Then the first step, double bar it. Then after double barring it, let us split this to get rid of this multiplication sign. Then we have A bar plus B bar. We have splitted only just this one. So we are still left with two words, double bar. Now, this, you have to negate your A and your B, join it with your NAND, and then negate it again. So this would be A, B. Negating it. Now, at this point, we have what? A bar, B bar. We have gotten this and this. Now, this is going to be giving us A bar plus B bar or bar, which is for this second word, bar. And then lastly, we negate it again. Having what? A plus B double bar, which is also the same thing as what? A bar plus B bar. And you know what De Morgan's rule is. Now, if I go to join the two bar together, the sign again will change. This also will be A dot B or bar. I hope you have seen it. So it follows the same principle. When you are asked to use a particular universal gate to implement another gate, that gate that you're meant to implement using this your NOR, bring it out, double bar it. If there's any multiplication sign there, change that multiplication sign to addition. Then you can then draw the symbol of whatever you have. So now let's go over to that of our XOR. Our XOR, we know that is representation is A B bar plus A bar B. This is the logic expression for your word, your XOR. Okay, so for our XOR, like we said, we write our expression down. A B bar plus A bar what? B. Now this is an SOP. An SOP means that we are having a sum of products. So for us to our laws will also apply, but it will apply in two ways. First of all, it will apply for the first signs and then apply for these other signs that are here. The double bar comes whenever you see your signs. So where we had one signs or either plus or multiplication, where we had only just one, we just did only one double bar. But since we're having about three of them, we are going to be having three double bars representing each of them. Now for this one, we're going to be having, for this bigger one, the one that is the one summing the two of them, will have a bigger double bar. And then for this one in between the two of them, we have the one joining the two of them together. Now this double bar, if I were to split it into two, since we're dealing with only just words, no, we'll be having for the first, only just this one, this last one, we have A bar, our sign will then change to plus, and B double bar, which you know is equivalent to what? Just B, plus A double bar, okay, this one is also still there, plus B bar. This will go off, right? Now we have achieved a NOR gate, another NOR gate, then finally another NOR gate, then we negate it. This will still give us back this if we are to solve. So in this case, where we had only just plus, that is just your OR. We need to negate it, which was the reason for our double bar. We also had multiplication in between them. We also double bar them too to get rid of the multiplication sign and then change it to what? Plus. Now, this is the diagram. This is what we're going to be using to make our diagram. So when we do that, we have our A, taking this one first, B, our AB. We negate our A. And there, we then join the two of them using our what? NOR. So like this, now we have implemented this one, which is A bar plus B OR bar. We have gotten this. We have gotten this. Now we'll move over to the next one, your A and your B. You can choose also to tap from here if you want. Now the one we're negating is what? Our what? B. We'll negate our B. So at this point we have B bar. Then at this other point we'll be having what? A plus B bar OR bar. We have achieved this, we have achieved this. Now the other one, I will join these two together. When we do that, you also achieve this too. This bigger bracket, which is the A bar plus B OR bar, then plus A plus B OR bar, then OR bar. We have achieved this. Then finally we then negate. And when we negate, we then represent this last words bar sign here. So it's not going to be everything here with another extra words bar. So we have succeeded in do what? In representing this. So our output here will be the double bar A plus B plus A plus what? B. Now, for us to check if this and this are actually the same. If this and this are actually the same, this will go off. And we are left with what? Bar A plus B plus bar. We have this. We're having double bar. The double bar goes off. Now we have this. Using the Morgan's rule, splitting this, we will definitely see we'll return back to this again. So we are actually what? Correct. So this is how you represent it. How you represent your XOR with your what? NOR gates. Now let us try for our XNOR. Now for our XNOR, we know this is the what? The logic expression. Now writing that down, we have A, B plus A bar B bar. Now, since we are having three signs here, You're going to be having double bar here, double bar here, and finally your bigger words, double bar. Solving this further and getting rid of a multiplication sign, you're going to be having double bar. Then for the first product, which is this, we'll be having A bar plus B bar. We have splitted this last one. Then plus, move over to the next one, keeping the first one, the second one. The second one, we split it to be having A double bar plus B double bar. And we know this is also equivalent to what? A plus what? B. So this is the diagram I'm going to be making. This diagram we're going to be making. Now, for the first one, we have our A and our B. We negate them. Remember, we're already using what? No to negate and not our normal inverter sign. So after negating, we are just trying to achieve this one. After negating the two of them, we will then NOR the two of them. So at this point, we have A bar, B bar. At this point, we're going to be having A bar plus what? B bar, or what? Bar. We have achieved this. Move over to the next one, A, B. Then we simply what? NOR it. So we can just have what? A plus B or bar, which is this. Now, for this other, we have achieved this and we have achieved this. And let's go for the next bracket, which is this one. Since we have this and we have this, we're just going to NAND it again, and we're going to be having these two coming together. So these two coming together will then form this, which is our what? A bar plus B bar or bar plus A plus B or bar, then general what? Bar. That is for this one. Then we then negate it finally, presenting the last words, the last bar on top. Now this one will then introduce the second word, the last bar, which is this. So finally, we have gotten that. So this is what we're having as our output. Remember, we want to use only just this, which what we have done so far, to implement this. Now you may looking at this and look at this and say, are they the same thing? Let us check. Now, if we are to having our two bar, these two will go off. Since they are bars of the same length, they will go off. Then we are then left with what? A plus B bar bar or bar plus A plus B what? Bar. We just sort for this one now. We have removed the first bar and we're left with this. Now, our De Morgan then said that whenever we see this thing, we can then split our, for us to split the bar into two, our sign will have to change. And when we do that, we'll be having A double bar dot B double bar plus A bar times what? B bar. We know double bar gives us what? A and B. we are back to what? To this. So we are back to what? To this. So that's for how to use your NOR to implement the other 6 gates. In the next video, we'll be talking about how to use your NAND to also implement these other 6 gates. The same principle also follows. Like, subscribe, share, and keep being the best version of yourself. See you in the next video. Goodbye.